Hey, welcome back, you guys. Lesson 5. We're finishing up combinations, actually. We're getting into some little more difficult situations with combinations, and that's really what this lesson's about. So let's take a look at the first example. Just remember, if you use the word and, you're going to be multiplying, right? And if you use the word or, you're going to be adding. Okay, let me just write multiply instead there. Okay, that's really the key with these first few examples. And always write down the game plan. Write game plan first, if you know what I mean by that. You'll see. Okay, the student council decides to form a subcommittee of 5 council members to look at how funds raised should be spent on students in the school. There are a total of 11 student council members. Wow, that was loud. Okay, 5 males, 6 females. Okay, and we're making a 5-person council. Okay, how many different ways can the subcommittee consist of? Exactly 3 females. Okay, let's write down the game plan. So, what would that committee look like? We would have 3 females. Okay, and let's see. There's 5 people on there, so we'd have to have 2 more people. And by deduction, they'd have to be males, I guess. Okay, so 3 females and 2 males. All right, so there's our game plan. Now we just follow that. Okay, order does not matter here. They're on a committee. Okay, so unless there's positions on the committee, it really doesn't matter the order. So 3 females. We better choose from the females. So there's 6. We're choosing 3. Okay, and, or what I wrote, okay, times 2 males, which is 5 we're choosing from because there's 5 males, and we're choosing 2 of them. Okay, that first number always has to be bigger because that's how many you're choosing from, and the second number is what you're choosing. So yeah. Okay, so if you work this out on your calculator, you will have, am I talking slow enough? Have you got the number yet? You should have, the first one would be 20 and the second one would be 10, and therefore that equals 200 different subcommittees with 3 females. Okay, now here's where it gets a little bit trickier. At least 3 females. Okay, let's write down the game plan, what that would look like. We could have 3 females and 2 males. Please don't abbreviate and with a plus sign here or something, because you're going to get mixed up later, because and is actually multiply. Okay, now, or you could have, what's another situation? You could have 4 females, that would be at least 3 females, and 1 male. Or all 5 could be females, so 5 females. Okay, now that you've got the game plan written down, ands are multiply, ors are add, and you just translate the 3 females, 2 male stuff into combinations. So 6 females, choose 3, and so multiply. 5, choose 2 for males. Okay, the word or, plus. Okay, 4 females, so we're choosing from 5 females, choose 4, and so multiply. 1 male, so 5 males. Oh, did you see what I just did there? Okay, so that should have been a 6 there. 6 choose 4. There are 6 females. Okay, 5 males, so 5 choose 1 here. Or, so adding, and then 5 females, so 6 choose 5. There we go. Oh, that's a lot to calculate it. So I will do that for you if you work all that out. Of course, we had the first number already. Oh, and when you have 5 choose 1, it's always just equal to the 5 then, if you're choosing 1, right? So that can shorten up your calculations a bit. All right, and if you think about the permutation formula, you can actually shorten that even more. 6 choose 5 is also just equal to 6. Anyways, we should get 281 different subcommittees. All right, let's look at the third one. At least 1 female. Okay, let's think about the scenarios there. That could be 1 female, 4 males, 2 females, 3 males, 3 females, 2 males, or 4 females, 1 male, or 5 females. Wow, that would be a ton of work, wouldn't it? Okay, do we want to do all that work? No, because there is actually an easier way to do this question. If the number of situations when you're writing down the game plan is just so many, right? Maybe using the complement event would be an easier way to go. So if we take the total number of committees and we subtract all the ways in which there isn't at least one female. So that would be no females, or we could write that as 5 males on the committee. That would be how many committees would have at least one female. Okay, so total number of committees, we don't care who's on there. So we don't care how many females or males there are. So there was 11 people altogether, and we're choosing a 5 council member subcommittee. Now we subtract all the committees that would have all males. So there are 5 males, and we're choosing all 5 of them, which is really only one way to do that. Okay, so if we work this on in the calculator, 11 choose 5 minus essentially 1 would give us 461 committees. All right, good job, you guys. Example number 2, consider a standard deck of 52 cards. How many different 5-card hands can be formed containing at least one red card? Okay, well, I'm going to let you guys try A and B on your own. Okay, if you need to look back at what the description of a deck of cards is, please do. I'll give you a little hint. At least one red card on a 5-card hand. You don't want to go at that question straight on, okay? That one might be better off doing the complement event. Whereas the second one, it's 6 of one, half dozen of another, which way you go on that one. You could go straight forward, but for any of these, write down the game plan first, okay? All right, we'll check back in a minute. Pause your video. Okay, so let's go through these. First of all, did you get the same answers? Let's check that. Okay, at least one red card. If you were to go the straight on way on that one, like 1 red, 4 black, 2 red, 3 black, yada yada, a lot of work. So best would be to go total number of combinations, we don't care, minus what isn't at least one red card, which would be 5 black cards. Okay, so total 52 choose 5. There's 52 cards. We're choosing 5 to make a 5-card hand. Minus, and then we got to choose only from the black cards. So there's 26 black cards, choosing 5 of them. Okay, put that in the calculator. We should get that. At most 2 kings. You could go either way on this one. You could go total minus what isn't at most 2 kings, which would be 3 kings, 4 kings, or 5 kings, but that's slightly more work than just going straight on, which is figuring out at most 2 kings could be 2 kings, 1 king, or 0 kings. Or let's write it, you can't just choose 2 kings, so 2 kings and 3 not kings, or 1 king and 4 not kings, or 5 kings. See how writing the game plan down here really helps, okay, with the ands and the ors and everything. Then you just turn that into combinations. Make sure when you're choosing not kings, you take the kings out, so 48 cards left, and yada yada, you should end up with that number. Okay, so exactly 2 pairs. This one's tricky. Okay, so exactly 2 pairs. Well, we know to choose a pair, we'd have to choose from 4 of the same card, right? Like 4 kings or queens or whatever. So 4 queens, choose 2, right? That part I think we're okay on, right? You choose 1 pair. Choose 1 pair. So that might be like 4 choose 2. And then the choose, let's call that the first pair. Choose, actually no. If you say first, that implies that there's an order. Choose 1 pair, choose another pair. Okay, so that would also be 4 choose 2. Okay, but here's the scoop. Who's to say we're choosing, I don't know, queens and 8s? Okay, it might be jacks and 2s, or 4s and 3s, or something like that. So here's the first thing we have to do. We actually have to choose which cards, you know, like aces or jacks or 8s or something, are going to be the pairs. So to do that, so we're choosing which are the pairs. Okay, and to do that, we have basically 13 different kinds of cards, all the way from aces, 2s, 3s, all the way to king. 13, and we're choosing 2 of them to be our pairs. And then after you do that, so and, then you choose 1 pair from, say it's jacks and 8s, so jacks, 4 choose 2. And then we're choosing the 8s, 4 choose 2. And then we're not done. We have to choose the fifth card. Okay, choose the fifth card, which we haven't done yet. So let's see, we have to take all of those cards that were the pairs. So 8 cards, 4 and 4, out of the deck, so we don't end up with a full house. Okay, so 52 minus 8 is going to be 44 cards left, and we're choosing just one of them to make up our fifth card. Okay, crazy, eh? That was a little tricky. All right, so the answer, after you multiply that all out, is going to be this. Okay. All right, good job. Let's look at the next page. Okay, example 3 looks at combinations which are equivalent. For the sake of time, I'm not going to go too heavy into this one and fill them all out, but essentially what this is showing is if you have, in this situation, 10 toys, and if you were to choose 2 toys from those 10, let's say I choose these 2, these 8 that are remaining, okay, the number of ways to choose 2 toys would be the same as if I chose 8 toys, okay, and the number of groups that would make. So just think about it. So whatever 2 choices I choose, there's 8 left behind, so that would be the same as if we chose 8 and left 2 behind. Number of combinations would be the same. So you can show that with factorial notation using your n choose r formula. It'd be 10 factorial over 10 minus 2 factorial and then 2 factorial. Okay, equals 10 factorial over 10 minus 8 factorial 2 factorial, or 8 factorial. Okay, and if you work those out, those will be the same, right? 8 factorial 2 factorial and 2 factorial 8 factorial, both on the bottom. Okay, 2 examples of equivalent combinations. Well, as long as these 2 numbers add up to this number, those combinations will be equivalent. So I could go 5 choose 3 equals 5 choose 2. Or let's say I have 26 choose 3 should equal 26 choose 23. 3 minus 26, or 26 minus 3. There we go. Okay, you could choose anything there. All right, so then they kind of demonstrate that here, that those are equal. Remember this other notation way to write combinations. All right, and algebraically, yes, we could show that as well, but we're going to skip that for now. Okay, example number 4. During a Pee-wee hockey tryout, all the players met on the ice after the last practice and shook hands with each other. Algebraically determine the number of players who attended the tryouts if there were 300 handshakes. Okay, so let's think about this, another situation that's a little simpler. Let's say we had 5 people in the room and we wanted to figure out how many handshakes could be created. Well, we would have 5 people to choose from to create a handshake, and to create a handshake we'd need 2 people to shake hands. So that'd be like 5 choose 2. Now in our question, we don't know how many players or people there are. So that would be our unknown. Let's call that n. And choose, still, to make a handshake, you'd have to choose 2 people. Now what we were given here is how many handshakes. So that's kind of what this equals. So it equals 300. Now we could do this trial and error on the calculator till we get 300, right? Go 6 choose 2, 7 choose 2, that kind of thing. Or we can do it algebraically, which is a good idea as long as this number here is a 2 or a 3 or a 1, something less than or equal to 3. So let's try this. N factorial. So what we're using is our n choose r formula from our formula sheet. Okay, so n factorial over, and our r is 2 in this case, so n minus 2 factorial and then 2 factorial equals 300. Okay, so if you recall, first of all, that 2 factorial, we're going to multiply that to the other side. So 2 factorial times 2 factorial, and if you recall, that's just equal to 2. So we would now have 600 on the right-hand side, 300 times 2. If you recall about the expanding the factorials, n factorial is bigger than n minus 2. So we would start by expanding n minus 1, n minus 2 factorial, and then still have n minus 2 factorial on the bottom. And guess what? Those can go. N minus 2 factorial is gone. Expand the left-hand side. We have a quadratic. And I'm running out of time to finish this. And then we're going to factor that. I was going to do that quickly, but it's too important. So we'll finish this up in part 2 of lesson 5. See you then.